Good morning to all the viewers in the YouTube video. So, in today's video, I'll be talking about virtual lab. So, what is actually a virtual lab? I'll be explaining later in the video, and what advantage we can gain from it. So, uh, usually for any students from the course of high school to the degree years, we'll be doing many physics experiment, and most of the time these are called as lab lab activity. But what does virtual lab essentially does is that virtual lab transfers all the data or all the equipments that we already have in the lab in a virtual form. So there are many benefits that you can derive from having virtual lab. So firstly, it is a damage resistant experiment. What do I mean by resistant experiment? It means that the equipments that you use will not undergo wear and tear. For example, in lab there are accidents do happen, and this sometimes cannot be prevented. Like students usually drop their thermometer, and we have leakage of mercury, or when we heat up conical flask too hot, it cracks under temperature, or when we keep using the same burette or pipette for along with certain acids, it causes wear and tear of the inner wall of the glass. But virtual lab recalibrates your calculation using accurate measurement, but in the form of virtual equipment. That means you have a virtual thermometer which actually does the job for you. So secondly, we go to what is the other benefit. It is an experiment that can be done by anywhere and anytime. This means that you can even perform your own solo experiment, because you don't need many members for you to actually carry out the experiment. You don't need someone recording the time and someone analyzing the graph, because all that is done for you in this app called Virtual Lab. And what is meant by anytime is that you don't need to have like permission of your teacher or your lecturer or even your lab assistant, because you can do it from your home while sitting at your laptop, or you can do it even at the bus stop, and etc. And then there's also the issue of how effective it can be. So usually when we carry out experiments in lab, there's always human error that happens, and there's always random and systemic error. All this because there might be faulty in the instrument, or it might be wrong procedure you have done. So all this affects your data little by little, and it causes a percentage error. While if you use virtual lab, your percentage error will almost be zero, because you are using a software which has been programmed carefully. So therefore, you don't have random errors which human usually does. So your data are more accurate, and you can derive a better graph from it. And not only that, there's also the issue of efficiency. So usually when we have a class group of 20 people and the equipments that we have in lab are limited, what happens next is that we have to share the equipments. When we have to share the equipments, it's much more slower for other teams to derive their graph, or to derive the data they would like to have. But in virtual lab, essentially anyone who has an internet and that app can do it themselves. So there's no issue of sharing equipments that needed. So in conclusion, virtual lab beats the lab experimental lab by many levels. Only con that it actually has is that students don't actually feel the tensions when doing an actual physics experiment, because all this is done virtual. So you don't really experience the hands-on tasks that other students will be experiencing when you're doing an lab experiment inside the lab. So thank you. What we have today is the virtual experiment of a ball falling from a certain distance. So this experiment is actually about Newton's theory on gravity, on the speed of gravity an object faces. And as we all know, gravity is influenced by two things. One is the size of an object, and second is the weight of an object. The reason here is because different sizes will affect different air resistance, and the air resistance will affect the speed of which the object is falling. Like in this case, we have a ball. So while playing this video in the behind, I'll be explaining to you all how do we use it. So right here we have the graph, the ball falling down, and you can see here it's actually tabulating the data. So yeah, you can also set the displacement we want to have. For example, at here I set it to I set it to 1 meter, and the ball moves up 1 meter, and it tabulate the data again. So at the on the left hand side, you're plotting not only the time but you're also plotting the speed of the ball falling down. And here I increase the displacement by 4 meters, so the ball falls from a greater distance, and the gradient of the curve is much more steeper. And then here I set the displacement to a higher, which is 6 meters, and we will eventually get a much more steeper curve. So in all these cases, the ball is actually free falling. And now I choose the ball to not be free falling, but it experience with air resistance, with a small air resistance. So now you get a different graph, and the velocity will be definitely be different because of the upward resistance. See, the time here is longer. We tested it again, but now we are calculating the rebound speed and the time for that, the displacement when it rebounds. So yeah, this is a rebound, and you see the graph here. So eventually the graph goes on and goes on for the first bounce. Then now we are moving to the second bounce. And now we calculate, when we tossing up, what is the upward velocity and downward acceleration of the phase. So you have a different graph here, a parabol shaped. And now we toss up with a fixed displacement and velocity. So 2 meters, and we toss it up from 2 meters, we get the data here. As you can see here, it starts from 2 meters. And you can choose a variety of other options. And this is for the last one, which is uniform motion of the ball. And that's how we use the virtual lab.